Uh, pleasure to meet you. So the talk is about this kind of architecture for providing this kind of really generic multi-purpose AI from aggregate industrial data. And but first of all, I would like to introduce myself. I'm Antti Rauhala. I have been working for quite a while as the lead data scientist. I have worked in customer service personalization, NLP, job market matchmaking, process optimization, smart shares analytics, and so forth. And also recently in this kind of industrial landscape. Also, I have worked in Futurice, and we have actually started also this kind of AI technology company together with Kai and Vesco. We are creating a new kind of AI platform and product, which we believe to be somewhat revolutionizing the way how AI is used. And this talk is inspired by both these kind of new technological capabilities, which I think have not seen before in the world, and also by this kind of past work, and by the precise discussions discussions with our industrial customer and also with some other heavy industry customers. Unfortunately, right now I cannot name the names, so I'm going to have this placeholder for a large global machine manufacturer. But the basic setting is that bringing AI to this machine manufacturing is not an easy domain. And they are in fact, well, it could be extremely rewarding. So what became quite quickly very obvious is that these companies, they may have actually absolute tons of data. And it is extremely interesting data which directly relates to the kind of key KPIs, the kind of key goals, what any kind of company seeks to drive. So we have different kind of processes, different kind of domains of the company, like subcontracting, R&D, customer sales, different kind of installations, actual IoT data from operations, support, repair, manufacturing. And this data can be used to drive better product experience value, to drive sales, drive just overall customer satisfaction. But also it can be feedback to the process in order to support the process, automate the process, and just make everything work better. But what seems to be the situation is that there are tons of applications, but the data is partly unused and even greatly unused because there are actually few real challenges in using AI in this kind of setting. So one of the challenges is simply the fact that we have tons of data and some simple use cases. So let's consider one application for this data. So we want to do root cause analytics, and it's very simplistic. So we have a machine and we have recognized that it overheats. What is the cause for it? And the cause actually can be from any of these operations or domain. It can be caused by faulty parts. It can be caused by certain components. It can be caused by R&D. So maybe the machine heating capacity or cooling capacity was underestimated or underdesigned. Maybe we sold too small machine for too heavy usage. Maybe the installation is in Dubai and it is simply overheating because of the extreme heat at the location. Maybe there's some external damage which we could actually see in the IoT data, or some wearing and tearing. Maybe there has been some kind of similar cases before. Maybe in the support stories, there's some kind of event which explains this or has caused it, or maybe even the customer hasn't actually maintained this system at all. So apparently these kind of things are even possible, that the customers are not maintaining their machines. And the problem here is that we have a relatively simple problem, but we have actually tons of different data sources, very diverse data sources, structured data, unstructured data, from possibly dozens of different databases in order to answer this simple question. Another challenge is that quite often the only way how insight can actually drive the business forward is that it somehow affects decision, so that we can get better decision which will have positive impact on the KPI. So this is the basic idea. And quite often this kind of decision making, it goes very much in details. So if we have the machine overheating, what we are going to do about it? It is some specific machine, it is some specific circumstances. We have tons of insight, but it's very difficult to bring the right insight in the right decision, in the right place, in the right time. And this is actually quite a major problem. How do you do this? How do you bring the right insight in the right location? And this is, it has somewhat straightforward solution. So if we have some, let's say, support tools, if we have some kind of sales tools, some kind of digital tools what we are using within the process, we can integrate the insight in the tool and we can really kind of bring the right insight, let's say about the kind of situation, about the machine. Maybe if we have some problem, we can already bring the solution in that specific context. But in here the problem is to a degree that this kind of integrations, they can be kind of expensive, and we run into a problem scale. So we may have some like half dozen processes which we would like to support. We may have some like half dozen or dozen different data sources, and each of these integrations, they actually can be kind of expensive. They require design, they require specified solutions, and it's a bit tricky situation, and it becomes even trickier when you recognize that actually modeling and this kind of AI part, it is not very cheap, and we have several steps in order to bring some kind of intelligence functionality into some process. Let it be R&D or let it be support or repair or whatever. We need to specify the problem, we need to get the data, we need to prepare data, we need to do modeling, evaluating, some kind of feature refactoring. We may need to aggregate a lot of data sources together. We need to make the deployments, we need to do the live data integrations, get all the pipelines to actually kind of update the data and train, update the models and so forth. And we need to do the final application integration. And this can take weeks or it can take months. And it can cost some like tens of thousands or even hundreds of thousands of euros. And now if we, and we may have actually a lot of concepts, a lot of good ideas, great ideas about this kind of different smart functionality, what we want to bring into some specific process. And each of these functionalities may require its own modeling and its own process. And if we have several core processes, if we have several smart features per process, we run in tens of models or even more models. And then we have the integrations from different sources to aggregate to the models, and it all kind of adds up, and we possibly talk about quite multi-million investments, and because the data is obviously extremely valuable, and it really kind of tightly integrates into the business. It can really kind of drive and automate the process. We are also talking about quite major kind of returns, but this is a kind of, it is expensive, and it means that we have quite long roadmaps for limited size of data science and technical teams. So this is kind of setting. So we have the aggregation problem, we have the scale problem, we have the integrations, we need to support digital tools, people, which also brings its own complexity. And we have actually quite high unit cost of creating one smart functionality. And the benefits may be high, but also the costs are high. And now if we think about the kind of solution for this kind of setting, I think the problem itself kind of defines the solution. And their kind of problems already exist in a way, but I think they are not kind of, they don't address this entire problem landscape properly. So we have the aggregation problem, so we would actually need to aggregate all this data and combine data in order to make sense of it. And obvious solution should aggregate the diverse data. We have the scale of applications and diversity of applications, which means that solution actually should be quite generic. And they're generic tools, but they require a lot of skills, some like data scientists in order to kind of use them. We have digital tool support, which means that the solution actually should be kind of real-time, it should be user-friendly, it should provide diagnostics in it. We have the integrations, and the solution should make the integrations non-issue and somehow automate the integration process. And we have cost of creating, this high unit cost of creating one smart functionality. And this is one of the biggest things, that how we can actually dramatically cut the cost of adding one smart functionality into one of these heavy industry processes. which I think is kind of interesting question. And this is kind of the solution in this kind of setting. So what we have is that we would actually kind of want to have some kind of solution which actually provides us real-time and user-friendly, very diverse generic results rather immediately and rather effortlessly. So with minimum investment, very this kind of generic functionality. It does the aggregation and it hides all the integrations from lower levels. So data lakes, Hadoops can kind of do some part of it, but we still run the problem of needing to quite expensive modeling on top of it. Of course, this kind of solution, it is not easy to provide, and it actually looks much harder problems than the original problem itself. And now we actually have to ask that, can this kind of solution actually be created? Is it even possible to do? And obviously, when we're talking about technical problems, well, there are kind of interesting technical questions, but one is this: that what would actually happen if we do this? If we would do this kind of very deep integration of databases and AI, and it may sound a bit irrelevant, but it is actually surprisingly relevant. We did this kind of operation, and what it does is that if you specialize the database, so this is a bit technical stuff, but if you specialize the database for AI operations, for statistics, what you can do is that you can count in microseconds some like really large statistical operations. And if you can do this, you can actually count in real time in tens of milliseconds, thousands or tens of thousands of statistical operations, which actually makes it possible to have ad hoc models. So instead of having some like really long modeling process where we create models, where we deploy this process, we can do models like this. You want predictions, we tailor a model for you for that specific prediction. If you want to have some kind of matching, some kind of personalization, some kind of smarter operation, we can do models like this to fit your needs. And if we have some kind of complex scoring operations, let's say in personalization, we have a lot of content or different kind of products or offers what we would like to offer for the customers. We can similarly create models for that specific purpose and we can score the content very quickly. The second thing is that by combining database and AI, obviously the database is kind of ideal for aggregation. So we can have structured tables there, we can link the tables, we can do operation through the tables. But also one interesting thing is that all these kind of integration problems, they kind of disappear from the kind of modern steps. So when we had in the first place the pipeline of getting the data, it disappears, preparing data, it disappears. The data is already prepared in the kind of database. What used to be actually many week operation of creating a single model and deploying it becomes an operation what can be done in a fraction of a second, real time, in some like tens or hundreds of milliseconds, like this. And the entire process of using the AI changes entirely. So instead of creating models, you just ask for intelligence and a bit like in SQL like queries. And it provides you answers, even with rather big data sets. Another thing is that if what would happen if we use generalized Bayesian mathematics and very diverse optimizations. And what actually happens is that when traditional models do some like classification or some like point some like numeric predictions, it is actually possible to make rather generic AI functionality which provides you both predicting, estimating, classification, and this kind of personalization, matchmaking settings. So if you have some question, you can just ask from the previous data to match the question in some existing answer or solution. This kind of personalization, if you have some customer company and you are wondering that what kind of products you should offer for this kind of company in order to maximize the buy rate, it can be done quite easily, and it can be actually done real time. So what we can actually do is that we can provide the generic functionality and quite generic AI in real time. The second thing is that when we do this very diverse optimizations, obviously we had structured data, we had linked data, we can do inference and predictions and the smart operations through the links. So we can link the IoT data with let's say support data or some other data about the churn or whatever. But with the optimizations, we can also bring text in, we can process text, we can do inference and an AI with text. We can bring a lot of scale in here because the system is optimized for scale. And we can actually take very kind of diverse generic data in, and we can get very diverse generic functionality out, which also support the aggregation goal. And because we have a database, we can do traditional database operations there, and the database operations integrate nicely with AI. And we actually did smart search, this kind of generalization also. And we can provide this kind of search engine kind of functionality. And this is kind of what this kind of architecture, what this kind of solution looks in this kind of landscape. So we have the diverse tools in there. We have the diverse data process, and we can do the same thing as data lakes and quite a lot of systems can do by providing aggregation, by hiding the integration from the users. But what is very unique is that instead of having this modeling process, which are expensive and which take a lot of time, we can just by querying, by just asking questions, predict the, let's say, churn likelihood for this kind of customer, explain it, find solution for this problem, explain us what drives sales, what kind of customers actually buy us, what kind of things in the sales process actually further the sales. And we can get this rapid generic operation immediately, very quickly. Now, obviously, the question is that can such architecture actually work in real world? So it sounds like it may be a bit too good to be true. We are still in a bit early steps in here, but we have already done this kind of, with heavy industry companies, kind of smart search in customer support cases. And we didn't just provide smart search, we provide analytics. We provide information about what are the most common problems. If we look at some kind of problem category, what kind of things the problem associated with. So is it some customers, is it some kind of certain kind of keywords like heat or something like this, which provides more like context to the problem. With Columbia Road and Helsingør, which is a Finnish e-commerce company, we actually created this process automation by matchmaking IKEA products with Helsingør products. We have done analytics for a large media company for having any kind of text, any kind of article, and we can provide kind of estimates of that how likely the what the KPIs for this article are and what drives the KPIs in the article, what predicts success. And we have also done this success analytics for Finnish construction companies. So we have some kind of projects and we have some parts of the project, and we can just ask that what makes project or some part of the project successful. And we also have another startup which has done conversion analytics quite successfully with this kind of system. So it can be done. And we have also done with Futurice before with different technology stack, but very kind of similar techniques. Personalization in media context with 50 million impression data. So it's something like 30 gigabyte of information. Real-time personalization, matchmaking for a mid-sized human resource company. We had some like 250,000 profiles. We had 500,000 features, just on an enormous amount of data. And we could actually do this kind of matchmaking in some like real time in less than 100 milliseconds. And we have done very successful process automation with very impressive results in financial processes with this kind of system, with absolute huge amount of training data. And we have put this in productions with success. So sort of our belief is that this kind of solution and this kind of approach, it can very much change the way how AI is used. So instead of having this expensive modeling and instead of having this major problem of scale and complexity, we can ignore quite a lot of it and just kind of get the AI by request. So we have a kind of oracle which is going to answer our questions immediately, both from the past and of the projected future. And this is interesting architecture. I think this is interesting for this context in here. And we are looking also for partners to try the solution. And that was it. So thank you.